Okay, sir.
Right.
Okay, sir.
Okay, so we are at this step result extraction. So we already done extraction. हम कैसे निकालेंगे? So we have this Excel sheet that is ready with us. So I think you are asking about this Excel sheet, correct?
Yes, sir. It's coming ref, sir.
It's I'm not able to
REF,
hear.
REF, sir. That one. Some values
Where
down, sir. Here only, sir.
uh, I don't able to understand what you want to say.
It's coming error, sir. Some this one, sir. Column tabs. It's showing
Hmm.
REF means means
Ref,
refer. It's showing.
in which line you want to say?
There, sir. It's one. That yellow line is there, no, sir. There at down, sir. Full down. Uh, Somewhere here, sir.
So in your Excel sheet.
Yes, sir. It's when I downloaded. It's showing like that, sir.
Okay, so you have to put all these values which is highlighted in yellow. Okay, so these are the inputs. Based on that, you will get the answers. If you don't put or if you don't provide that input value, so that's why it will ask some. It will ask you the reference. Correct.
Okay, sir. Yes, sir.
So unless until you haven't put any values that is relevant values, so you will not get any output from that.
Okay, sir.
Okay. So like I will just start from this again. So this is the math, not MathCAD, and this is the Excel sheet that we have created for design of rectangular walls. So all these are the some basic inputs like grade of the concrete, grade of the steel, unit weight. It's very self-explanatory. If you just go through that, you can understand what it want to say. Okay. Last time also I covered this. So only you have to change only these values which are highlighted in yellow. Okay, don't need to change anything which is other than the yellow. Okay, because it is automatically taken or automatically considered. This one also, yes, so you have to put these values manually. Okay, so next tab, now we have to check for the tank deflection. So I will just delete all these values. I will go to my stat. Okay, so I will go to the post processing mode. I will just keep only service level load combinations. I will get displacement. I will just go to the summary. Now I will use the group range group only walls. Okay. So maybe I can create one more other one another group also. But like based on this, I'm sure that the deflection values are pretty much less. So maybe I can directly use, or if not, then I will go to the again create one more group entire wall, because right now I have only long wall and short wall, but I don't have entire walls. So I will just create one more group walls to consider, or four walls. So I will just go to the front view. This way I have selected all four walls except top and bottom slab. Associate, yes. I will quickly run analysis. Now I will go to the post processing, just keep service level, load combinations, displacement, summary, result setup. I will go to the group only walls. Now I am getting the deflection values for only walls. Copy. I will create one more blank sheet, paste, and paste all these values. Wall deflection. I will copy this all values, go to the original sheet, select here, right click, paste special, only values. Okay, so now I'm getting the maximum dif vertical allowable is for I think 13 mm. Allowable is 6.22. Maximum 6.22, and lateral is 1.4 something. Okay, so your deflection is now pass. Okay, now what is next? So these are some design parameters: FY, FCK, grade of the concrete, elasticity, modulus of elasticity for concrete, modular ratio. So you have to put all these values. You have already provided at the first, so it will directly automatic linked here. So you don't need to do anything here. Okay, so just go to the design of walls. I will delete all these values. Okay, so now I will delete this also. I don't require this. Design of walls, stat group analysis, ULS. Okay, so again I'm going back to the plates. Just check anything, SX, MY, FY, whatever it may be. Just go to the summary, result setup. Now you have this service level combinations there. For design you need factored. So change the load combinations. Consider only factored from 200 to 300. Range walls, that is fine. Select, copy this entire to your blank Excel sheet. Just adds here walls ULS. Okay. So now copy this only plates and all these results. Copy, go to the tank, just place here, paste special values, done. Okay, so now maximum MY, maximum MX, it will automatically taken from this table. Everything is there. So just if you go to the stat, you will also find this. Okay, 92, you can see this highlighted numbers 92, 92, MX 118 and minus 118. So same thing was done here in Excel sheet. It will automatically calculate or automatically extracted the maximum values, minimum, maximum MY, minimum MY, maximum MX, maximum minimum is positive, negative. Okay, same thing with shear force also. What is our wall thickness? It is given already on first page. It is calculated the effective depth based on the bars, cover we assume 50. Okay, so now you have to adjust reinforcement. Okay, so red means it is fill. So assume we have provided for horizontal bars. So you can see this horizontal water face means inside face. What is for 500 thick? We need 600 square minimum AST, and required AST based on the moment is 556. So minimum AS reinforcement is governing. And currently what we have provided, we have provided 12 diameter bar at 200 it's filling because 452 which is less than 600. That's why it shows as a fail. Okay, this is okay. 10, so at 150, so I will just change this 200. Let's see 150. Okay, so now you can see this. So 12 diameter bar at 150 center to center are safe. Now vertical face, which means water face means inside, which is AC minimum is same 600 required for as per bending moment 489. So again, this is governing, and what we have provided 10 at 150. So we are providing too much reinforcement. So maybe we can change this. We can provide it 8 or we can just, this is something incorrect. Okay, formula was incorrect. So now you can see if we provide 8 at 150, so it's failing. So maybe we can use 10 bar. Let's see what happens. Still not good. Good. Okay. So you have to just play with number of bars and number of spacing. Something happen.
I said this only, sir, that time.
Okay. This is the horizontal. No? Hmm. Okay. So now it is correct. So what happened? Maybe the formula was just drag drop. So that's why what happened. Instead of small d, it is taken as a cover 50 That's why it was not correct. Okay. So now again we can will try to little bit reduce because we need only 600 reinforcement as against we have provided 1131. So maybe we can increase the spacing. Good. Can we increase further more? Let's say no. So just stick with 150. Here also looks like fine. Everything is fine. Maybe you can try with other instead of someone wants to go with the 10 Let's say what happened. It's failing. So you can also adjust the spacing. Instead of 150, you can just go with 100 and just check whether it is fine. So it's up to you. So which kind, what type of diameter, which diameter of the bar and spacing. Okay. So generally go with uniform spacing and uniform bar diameter. So it will be easy for construction also. Correct. So this way you have done with the reinforcement. Is it fine? Is it okay? Correct. Understand what you need to do.
यस सर। सर इसमें पूछना था
Yes,
ए
sir.
एएसटी और एसटी रिक्वायर्ड हम लोग को हैंड कैलकुलेशन करना होगा या ऑटोमेटिक कैलकुलेशन हो जाएगा जब इनपुट करेंगे स्टैट प्रो का डेटा इसमें तो?
Yes, ये automatic हो जाएगा. ये it's depend on the required means it's depend on the bending moment, and AST minimum depends on the your thickness. If you change the wall thickness, if for example if I instead of 500 it I will go with say 650, it will change up to surface zone. Maybe I will change to 300. Yes, can you see this?
यस सर।
It will change. So because what happens, so minimum reinforcement is depend on thickness of the wall. So from external face to center or first half of the layer, it will be considered. If you go further beyond that, it will not affect anything. So if I reduce again 150, it will again change. So at a point, if you increase the wall thickness such a way that it will not change. So let's 400, 500. Now if you change further that, it will not change anything. because first that layer, maybe you can just go through the IS code so you can understand what happened exactly there. Okay, if I make 1000 also, it will not change anything. Okay, it will change automatically. So you don't need to do. This will also depend on the bending moment. Okay.
Okay.
So currently if you have maximum MX is 118. Okay. So it is taken from the STAD. I'm just taking one example. Instead of I put 500, I am giving this as, can you see this? This value is changed.
Yes, sir.
Okay. So this Excel sheet is designed such a way that you have to just follow this step, just change these values, otherwise don't do anything. Otherwise it will be very problematic for you. Okay. So same thing you have to do with base slab, same thing. Now roof slab, so same thing. If I go to the roof slab, set up a range roof slab. Okay, I am getting all these values for the roof slab. Go to your blank Excel sheet. Roof ULS minus factored. Now just copy this, all the values, even though you don't require this column J, but still fine. Go to your main sheet. Delete all these values. I need to copy again. Paste special values. Okay, now you will get all these values. Now all the rebars are failing because we have provided 8 mm. Okay, so just check with what happened. Just go with 10 mm. No. Well, fine. So just changed. I'm just changing it to 12 mm. Done. Okay. Also we are checking for the crack width also. So we have taken bending moment and those things. So what happened? Like if we are designing our tank as per this limit state method, we have to control our crack width to 0.2 mm. So from more than 0.2 mm, it's not allowed. So that is also you can, what happened? The Excel sheet is sometime get stuck. Automatically closed. No problem. I will open again. Oh no, not this one. Not this one. Not this one. Okay. So if you see the row number 28, okay, what it's saying, limiting crack width as per IS 3372 702, maximum crack width is allowed as a 0.2 mm. ओके, सो अगर अपने टैंक में क्रैक होता है तो उसकी विड्थ कितनी होगी, मैक्सिमम एज पर आईएस कोड. सो कोड इज अलाउइंग दैट 0.2 mm. एंड हाउ टू चेक? सो टू चेक दैट, फॉर एग्जांपल अगर फिर वी विल गो टू द wall. So we did this design, okay, but we have in design we just find out the reinforcement required, but we haven't checked the crack width. Okay, how to check that? So go to again these results, just change the setup. because all of crack width is always check for the service level condition. So again, I'm changing it to service level or unfactored load combinations. Go to the group walls. Okay. So I have copied this entire results. Copy paste here. Wall service level means SLS service levels. ये कॉपी नहीं हुआ, सेव नहीं हुआ, इसलिए गलत आ रहा है.
ओके सर.
ठीक है, लास्ट टाइम ये मुझे सेव करने का टाइम ही नहीं मिला, वो पहले से बंद हो गया. ठीक है, ये इसलिए आया था कि not this one. Yes. So we are talking about this stat group analysis SLS means service level. So I have to delete this. Go back to this blank Excel sheet. Copy all these plate numbers and this entire table. Paste values. Okay. So now what we are getting? We are getting maximum crack width is 0.65 mm. So is it okay or not? Because we are already limited, our crack width is to 0.2. So that's why it is more than that. So what happens? So our design is failing because it is greater than. So what we need to do, again, go back to your reinforcement. We have provided 12. Is this correct? Yes. Okay, so still we want to reduce the spacing. So what we will do, instead of 10, I will do, I will go with 100, 100, 100, 100, and instead of 10, I will go to the 10. And let's say what will happen. Okay, so still it showing filling 12, 12. Something is incorrect. This value is not going to change.
So increase the spacing. 160,
Spacing.
170.
No. The
Spacing.
cell number is showing 32, right, sir? Thank.
इन सेल नंबर इंक्रीज किया तो क्रैक विड्थ और बढ़ेगा.
Cover increase the cover.
No. 32 and Z32. Okay.
It's showing the cover.
That's why tank wall. So we have to adjust here. Thickness, bar diameter, spacing. Okay.
So there is his REF.
Reference.
It is not required right now because tension moment, that's fine.
So IJ32, sir, cell number 32. Is it the same page number?
Yes, wall tank, same thing. Actually, maximum crack width is 0.20. Limiting. Okay. So that is not reflecting because it should be there. You cannot change at any part of any error. Okay, do give me a one session here. I will just investigate what exactly happened there. But generally, what happens? So we need to adjust our number of bar and need to decrease, not increase the
Why
spacing.
don't you press
So,
F2 and see, sir? Sir.
हाँ?
The crack length reference का cell था ना sir, उस पे click करके F2 दबाइए sir. It leads to the source cell where have the link has been taken from. No. In a main page, sir.
Here.
In a main page, yes, sir. Come down. Click F2 on that. Let the cell be selected and click F2, sir.
Yes, done.
It is showing the same, but the page is a different page, right, sir?
This one, the page number is this. Yes, the tank wall I2, I32, and Z32.
I32, yes.
That's why I'm just going here, and because those are the combined cell. That's why.
Okay.
These the 32. Oh no, not this one. This one 32, and these combined things.
32.
Yes. So it's
Case
merged. That's why I and J. It's showing I and J. But I will check what exactly happened. It should not happen there. But sometime I don't know. Means maybe during some drag and drop, it can be possible. But I will check what exactly happened. But okay. But I want to say, like, if you go here to the main wall, so if this crack width is more than that, then what you need to do? You need to update the spacing such a way that so your crack would be less than 0.2 mm. Okay.
Yes.
Just check here. Same thing here also. Something looks like formula was get changed. That's why it happened. But okay, I will check what happened there. Filter. Okay. So I have the main copy on my laptop. So from that I will just pull out and I will share with you. Fine.
Okay.
So where we are, so such for each element we have to do like this. So we have to paste all the results here. We need to update the spacing of the reinforcement here and just check with whether this crack. Now you can see this, the crack width is 0.15. So it should be less than 0.2. So yeah, there will be some manual manipulation there. So in terms of the rebars and the spacing, if you are done, so yes, so same thing needs to be repeated for wall, base slab, and roof slab. So once you have done, your design will be done. Okay. So this way we have completed this result extractions. We will again repeat it by tomorrow when I will just pull out that original Excel sheet. So we will just check why it is not working for that crack width. But otherwise it is very straightforward. Okay.
सर स्टैट प्रो में भी तो हम लोग डिजाइन कर सकते हैं इसको.
नहीं, मैं नहीं करता स्टैट में, क्योंकि लास्ट टाइम भी मैंने बताया कि उसके रिजल्ट्स मेरे हिसाब से नहीं आते एज पर व्हाट मैं एक्सपेक्ट करता हूँ। उसके मैनिपुलेशंस कैसा होता है, एरिया ऐसा, तो आई नेवर डू इट. I go with manual calculations or my this Excel sheets.
Sir, I have one doubt.
Mhm.
While applying the load, like
Hmm.
a soil load,
Hmm.
which is acting on the walls,
Hmm.
in the window, in the plate loads where I have chosen the hydrostatic and selected the plate.
Hmm.
In that case, why we are selecting interpolating along the global axis? Why? Because that pressure is acting in a x direction actually.
Hmm. Okay, let's say consider this wall. Okay, this one, fine.
Yes, yes.
I will go to the load, soil load. I will go to the front view. So from outside, it is applying to the plate load, correct?
Yes.
So what is your query? Like you want to say that?
Interpolating along the global axis, we chosen as a y.
Hmm.
Why we consider as a y? Because it is horizontally, no?
No. So if you go add plate loads, hydrostatic, suppose select this plate.
Yes.
So what we have to do? So
That interpolating
direction.
along
No,
global.
no, interpolate means along which global axis. Stat को कुछ समझ में नहीं आ रहा है कि horizontal means ठीक है. Just make sure that direction of pressure वो कौन सा है. So which is that direction of pressure? So we know along local Z, correct?
Local
we are
values.
Yes, so we have select this one. So we are not going with GX, GY or GZ. That is the global axis. But
Yes.
we are selecting global local Z. Okay,
Yes.
local Z ठीक है. Okay, but which local Z? So for that also STAT needs to understand interpolate along global axis. So maybe what I will do, I will try to open this paint. This is my Y, global Y, correct?
Yes.
This is my global X, and this is global Z. This is my plate. I want to apply pressure. Let's say its local axis is X. Okay.
Okay.
Let's say, or maybe what I will do, this is Z. This can be also happen, correct?
Yes.
So this is Z. We need to apply the local Z. So this is local Z, but STAT want to know. Apply local Z, that is fine, but STAT wants the other direction also. So that's why it asking about global axis, interpolate. So with reference to this vertical, we are applying the horizontal as a local Z. That's why it asking. So if you select up except Y or Z, your load will not be get applied. You will try at your side. It will not add.
But in
Okay.
the loading condition, we used it as a y.
No. In the loading condition, we are definitely direction of pressure is local Z. So all
Yes,
the
yes.
your loading will be applied to the local Z. But again, we need at least two direction. Correct. So दूसरा कौन सा होगा उसके लिए reference. So that's why we are using interpolate along global axis, and it is always Y.
Okay, it is always y.
It is always Y. So if you will try to add something like there, anything, or maybe I will add let's try one thing. Example. Whatever it. Plate load, hydrostatic load, select plates, select all these loads. Okay. Global Z, local Z, that is okay.
Yes.
Maybe it will be plus minus, so it's not the right point of discussion. We are discussing about the XYZ. Okay, so let's assume some values, maybe 50. Add. I have click add. You can see there is nothing adding here.
Yes. Yes.
It will not add anything. I will try with this one also.
Oh, it is not adding. Yes. Yes.
Because now what happened, your direction are both same, और same direction में कैसा होगा? So you are trying to add this triangular load in this direction and also in this direction. तो ये triangular उसको खड़ा रहना है, वो कैसे टेढ़ा ऐसा कैसा होगा? So you have to
बराबर.
provide some another 90-degree angle. So that is always Y. Okay.
Yes. 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 With respect to Y, global Y.
Yes, that's why. Because this is Z and this is global Y. Okay. In
Yes.
that
Yes.
case only this triangular can form, correct? So if I
Yes.
just click on Y, you can see. Yes, now it is added.
Yes. Yes.
So if I go and see this front view,
Yes.
so this is Z and this is Y. So
Yes.
one direction is fine, but basic thing. Okay. Try to explain in a simple way. This is your plate. So start, you are applying pressure in Z direction. And obviously
Yes.
you have to apply the pressure in upward direction also, like this. So you have defined only one direction, but again, whether it is in this direction or in this direction, you have to tell start, correct?
Yes.
Then only it can happen. Okay, got it?
Yes. Sir. Yes.
Okay,
And
so
also one more, sir.
Mhm.
In the last example, we have seen that there is an opening on the top slabs.
Mhm.
So we just need to delete those meshes as per the location of the opening.
Correct.
So there is no other anything we need to do, no, sir?
No. Suppose if you want to provide some opening at middle space, and it depends. Suppose you want to provide opening here. You can directly select that based on your size. You can delete and just check if all the plates are your design is failing. So then what you need to do? So you have to provide some kind of supporting there. Correct. Now if you provided opening here. So if
Yes.
I go to this, suppose this is your so if you provide opening like this. So in FEM model, yes, it can be up to based on the size and span. Sometime plain slab can be possible, but if your span is large, then what you need to do? Because what happened? So you are breaking this span, correct?
Yes.
Because this edge, this edge, this edge, and this edge is not supported, correct? For
Yes.
small tank opening or small span, it can be fine. But what happened now? This part this part is act as a cantilever. At this location there is a no support. Got it?
Yes, sir. Yes, sir. So there
So
might be winded beam.
yes, so maybe here you can provide some beam. Here also you can provide beam. So now what happen? You will get the span of the roofs will be like this. The span of the roof will be like this. Correct? So
Yes.
even though at this location also the span of the roof will be like this. So there is a nothing like that cantilever strip. So everything will be taken care. And why I'm added beam here, because this is the shorter span. Maybe someone you can add beam here also, but you are increasing the beam depth because it's not a critical span. By just observation, if this is my shorter span, I will provide beams here.
Yes, sir. Yes, sir. So here the plate elements will be separated in between these two
Yes,
beams.
yes. So what I can if suppose the thickness of the beam plate is 500, so maybe for this portion you can increase the plate thickness. So you will get some additional advantage of additional depth, maybe 800. Okay.
Yes. Yes, sir. Perfect, sir.
Hmm?
And whatever analysis we did
Mhm.
right now, is it a finite elemental analysis, FEM?
Yes, because we are using this finite method. Plate means finite analysis method.
Okay, okay. Now the mesh is in a square. We can do it in a triangular as well.
Triangular also, yes, but results are not in uniformly manner. So I recommend that if your geometry is a rectangular square, so go with the quadrilateral. Yes, at some locations, definitely you need where you need to go with the triangular also.
Okay, okay, okay. And sir, on the top slab, we have considered the live loads.
Hmm.
Likewise, if there is a vehicular load, then how we add in our loading conditions?
So in that case, what you need to find first, what is the load coming out from that vehicle? Okay.
Okay,
So maybe suppose if I will draw a section of roof slab. This is support. This is support. So this will be one tire, another tire, load, load. So you should know what is the load coming on that at a time, whether it is positive. Is it possible that two tires are coming at the same time or only at a one time? Okay.
okay,
So based on that, what you need to do? So you have to find out the maximum loading. So suppose your span of the roof span is short, at a time only one tire can be happen. So you have to design for two case. Consider the maximum wheel load at the center of the span, so that because of that what you will get maximum bending moment. Okay, which will be somewhere around center. Hmm. And what is
yes,
the second? So consider your maximum wheel load at a support, which gives you maximum shear force. So if you consider this two case, you are done.
okay, okay,
And it, so this is point load. Maybe you can consider convert it into the plate load also. So in that case, you need to find out the contact area of the tire. It is given that IRC. Okay, based on the vehicle H20, HS20. Based on that, all these things are given in that IRC book, IRC codes. So contact pressure, टायर का भी contact pressure रहेगा ना.
हाँ,
So based on that, you can, instead of applying a point load, maybe you can apply some plate load also based on that wheel. Okay.
yes, yes. ठीक sir.
ठीक है.
Thank you, sir.
Okay. Now only one part is remaining from my side, that is I will just provide you the updated Excel sheet, so crack width can be also get calculated easily. Okay, apart from that, yes, for the rectangular tank we are done. So now quickly we will start into the circular tank. Okay, for that I will share one reference drawing. Not this one.
Sir, most commonly circle tanks are used now, sir, nowadays.
Which one? I am not understanding your question.
Uh, Nowadays only circle tanks are used now, sir, in public, sir.
Which one?
Nowadays, sir, they're most commonly circular tanks are used now, sir.
No, I
Overhead
am
tank.
not like how ORED. For ORED, yes, maybe, and it's basically based on the requirement. It's not like mandatory that every time circular tank is always designed or used. So
Okay.
it's based on the process requirement. So process engineer, based on their hydraulics, the requirement and the process. So they decide the shape, and based on that we have to design.
Okay.
Just like architect plan the things, they plan everywhere like hall, kitchen, bedroom, and once it is get freezed, so we will get the architectural drawings and we have to design. So similar way process for that, most of the water retaining structures, what happened, like process engineer, they define all these parameters, like what is the height of the tank, what is the internal dimension of the tank, because they their calculation is based on that the volume of the water. Okay, so we have to intact those internal dimensions. So if they want 5 meter by 5 meter, so we don't need to reduce or increase that size. If they want height of the 4 meter, so no. So whatever you have to play, you should play with your thicknesses, base slab, top slab. Okay, so आपको अगर चाहिए 300 मीटर की वॉल लगती है, सो और इन टू एंड 5 मीटर है, तो आपने वॉल थिकनेस को अंदर करके लिया, तो 300 यहाँ से 300 वहां से, तो कितना हो गया 600. So you cannot go with 4.4 meter, because again what you are doing, you are reducing the volume of the water. Maybe it affect the hydraulics flow, those things. So basically geometry is defined by the process engineer in the industry. Okay, so now, yes, so this is the one practical example that I have. Hope you can see this PDF. So it is little bit complicated, but yes, we are not going too much that deep, but definitely we will cover the basic essential things. Okay, can you see PDF?
Yes, sir. It is like a tank, a circular tank.
Yeah, this is a clarifier,
Yes.
circular clarifier.
It is a
Uh,
water treatment plant, sir.
yes, this is from the water treatment plant, and this is the practical means. Based on this, we have given those drawing, we have issued those drawing for the construction. Okay, so this is the foundation plan. You can see this. The diameter of the tank is 13.2 meter. Wall thickness that we have provided 200 thick. Okay, we have 6 internal columns, but anyway we are not considering this because I don't want to make it complicated based on that the time constraint that we have. We have this reinforcement for the base slab. I will come it to the touch to this part later once we are design this. But
So what is that,
this,
sir? That one center circle, sir.
which one? This one?
Yes, sir.
This one, this is the have you seen the clarifier how it is?
No, sir.
Anyone?
No, sir.
Okay, I will have one photo.
Sir, it is a circular flow of water wherein most of the time
So influent supply करता है sir वो
नहीं,
central one.
I will no. Let me open the. I have one photo. Can you see this photo?
Yes, sir. Yes,
Yes sir.
Yes, sir.
Okay.
So clarifier. Okay. So we have this mechanism, a process mechanical mechanism, a bridge, which is continuously rotate throughout the yes. So to support at the center, we have to provide some kind of the structural arrangement. So this bridge can be rest on that. Okay. So that's why we are providing a concrete wall, circular wall at the center. So on which this mechanical instrument they can be get fixed on this center. Understand?
Okay. Yes, sir.
Okay. And this circular bridge is always rotate, and it is mix the volume of the water, so it will be get segregated and blah 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 things. I don't know exactly what happened, but basic things, yes, we have to steer that water, and so the solid particles will get settled down at the base, and at the base they have some pipelines through will they collect at the thickened sludge, and the clear water will be get collected from the here you can see another some launder channel. So this clear water can be come to this launder channel, and again it get distributed to further process. Okay, so this is the main concept of the clarifier. Okay. Laundry channel. If I take a cross section here, so we have this central pier here, where the bridge will be get supported, and this bridge will be always get rotated. Okay, and the solid sludge water will be coming out from this pipe, and the clear water, they have some arrangement here, so clear water can be flow into this launder and this launder, and it will be again collected somewhere for the further process. So basic principle like this. Understand?
Yes, sir.
Yes, sir.
Okay, so we are designing the clarifier of this diameter 13.2. So just ignore right now, we don't want to just go with this, but we have to definitely consider this because we have to support the bridge. If I go to the roof slab, you can see this is the internal wall, and this is the external launder. So this one, launder channel, that's why we can see this wall. Okay, and this bridge is supported over this. And if you see, there are some small openings to the main wall from which the water can be flow into the launder. And this launder is covered with the precast panel, or sometime it is covered with the grating. So if you go, I must say that during your academics you must visited somewhere to water treatment plant. So you must be stand over here. You just go through this. So just to observation, or to provide the path or walkway, we have to provide some gratings or some kind of the roofing material on the laundry channel. Okay, sometime it open also, so that is also possible based on the requirement, whether any inspection is required or not. Okay, so this is the top slab, slab or roof plan, sorry. This is not related with, there are some other structure which is we have included with reference to this. uh, so just focus on this circular channel clarifier. If I go to the next sheet, this is the section. You can see maximum water level, when if water is above, will go above this, it will be go to the launder. And due to the slope, we have some pipes here, it will be get collected all this sludge or the solid things at the down. Okay, and this bridge is supported to this central pillar. Got it?
Yes, sir.
Okay, so we are not considering anything like this, the baffle, those things. We are just keep simple. We are not considering sloping. We will just go with the plain horizontal slab, because it will be time consuming.
सर लेकिन अगर हम लोग को फ्यूचर में काम दिया तो टाइम कंज्यूमिंग का मतलब ये आप बताइए तो सबसे बेटर।
क्या क्या?
ये स्लोपिंग कंज्यूम करने के लिए किस तरह स्लोपिंग आएगा?
वो आपको प्रैक्टिस करना पड़ेगा ना, इंस्टेड ऑफ हॉरिजॉन्टल आपको उसको टेढ़ा करना पड़ेगा।
सर आप बताएंगे तो ना प्रैक्टिस करेंगे हम लोग।
नहीं करें, एक बार स्ट्रेट तो बताऊंगा मैं, उसके बाद मैं आपको बता दूंगा, क्योंकि अगर आपको स्टार्ट आता है तो वो भी आपको करना पड़ेगा ना, क्योंकि दिस इज द एग्जाम्पल, सो इट विल नॉट बी सेम. ओके,
ओके सर।
so every time you go with the practical real practical solution, that will be something different, so you have to think at your own. Okay, so ये मैंने प्लेट निकाली, तो प्लेट को मैं टेढ़ा कैसे कर सकता हूँ, इसको क्या कर सकता हूँ मैं, so we have to consider on that, think on that. Actually those are very basic things, so just select such a way that the node should be some, at that node there should be some difference, that's it, otherwise everything will be same. ठीक है? Okay, so this is the section. Maybe you can see this wall thickness are 200, base slab is also 200. So I will not going with this. We will just consider a flat slab with only middle things. Okay, so now we will start the modeling. This is like a different things. New, no. What is your batch number?
B20।
B20।
Okay. So basic things that required for the clarifier is the internal diameter is 13 meter, wall thickness 200. So what is the center to center diameter? 1300 plus 200 plus 200. तो कितना हो गया center to center? 13.2 meter, correct? Center to center diameter. Agree? 100 mm from this, 100 mm from this. So we are getting 13.2 meter. Okay, so first what we are going to fix the center of the tank. 0, 0, 0. So this is our center. Okay. So what is the radius? 13.2 divided by 2. 6.6. ये अभी मुझे किसी आपका नाम मैं जान सकता हूँ कौन बोल रहा था कि ये स्लोप में कैसा करना है?
अविनाश नाम है सर।
अविनाश जी, मैं आपको एक आइडिया देता हूँ। अभी ये मैं ठीक है, आप थोड़ा सा ध्यान से देख लीजिए। सो ये दिस इज माय center of the tank and this is the center of the wall. Okay, half radius. So what I will do, I will draw one beam. These are only the geometrical step, construction step, okay, that you have to follow. Maybe you can find some own things, but generally when I want to create a circular model, circular tank or clarifier, I will follow this. Maybe after some time you will have some better way also. Okay, so abhi maine kya kiya, I have just create a beam of 6.6. okay, so मैंने ये बस हाफ लेंथ का बीम किया. I am going into the front view. अविनाश जी,
यस सर।
अगर मुझे चाहिए मेरा स्लोप मान लो ये 0 है और ये 1 मीटर के ऊपर है, तो what I can do, I can select this node and I can provide some height to this. Correct?
यस सर।
हो गया क्या?
यस सर।
तो मैं प्लेट मेरा ऐसे डाल दूंगा जब मैं करूंगा, तो मैं बाद में आपको फिर से एक बार बताता हूँ. So right now I will just stick with 0, 0. I am standing in front view. Okay. So I have created 0. This is our origin. This is my center of the wall. Okay. Now what will be then? What is the next step? Again, I'm going to the plan view. Plan view. And I have to calculate the periphery of the wall. Can you calculate for me? This is the radius. So can you calculate the periphery? अविनाश जी, आप मुझे आंसर बताइए, पेरीफेरी कितनी आएगी?
2 pi r.
हाँ
एरिया ऑफ सरकमफ्रेंस सर।
हाँ, आप मुझे वैल्यू बताइए, पेरी कितनी आएगा, सरकमफ्रेंस की वैल्यू कितनी आएगी?
ओके सर। $136.77।
करेक्ट है? कैन यू?
नो सर, नो सर, एरिया ऑफ सर्किल।
41.46.
करेक्ट. अविनाश जरा आपने क्या किया मुझे
ये सर
बताइए.
गलती हो गया सर। एरिया ऑफ सर्किल मैंने निकाला, 2 पाई आर करना था ना, मैंने एरिया ऑफ सर्किल निकाल दिया था।
हाँ, तो कितना आ रहा था? 41 समथिंग लाइक दैट. दैट इज करेक्ट. 41.46.
41.46.
Correct.
Yes, sir.
41.46. That is correct. So again, what we need to do, I will just go here also. So this is my wall. Now again, just similar, like we have created some mesh based on the aspect ratio. So we have to divide this circumference such a way that we will get some aspect ratio at somewhere around 1. Okay, so now we have wall thickness is of 200. Okay, so हमें इसको ये पेरिफेरी को डिवाइड करना है. कैसे डिवाइड करना है मालूम नहीं, कितने नंबर करना है मालूम नहीं. स्टैट की लिमिटेशन है 100 के ऊपर लेता नहीं एट अ टाइम डिवाइड करना है. That is the problem of the STAD. STAD is not allow you to divide this more than 100 segments at a time. Okay, तो चेक करते हैं कि now we have wall thickness of 0.2 and 41 point कितना था 41.46. So let's say 41 round figure divided by 0.2 कितना आ रहा है 200 आ रहा है. तो it is more than that 100. Okay, so 100 भी नहीं लेगा STAD. 100 भी नहीं लेगा. And STAD, when we divide this segment, we need to consider only even numbers. So 99 will be also not possible. So we will just go with 98. Okay. Understand what I want to say? STAD is not taking more than 100 segments at a time. That's why maximum limit is 100. 100 will नहीं लेगा. Okay, 100 नहीं लेगा. 99 is odd figure, so I'm not going with 99. So रहा बचा 98. Definitely you can go with 96, 94, 92, 80. That is fine. But I will go with the 98. So what I will do, I will go to the STAD. I select this beam, okay, and go with the circular repeat command. Here, circular repeat command. Here I will select. इसको मुझे repeat करना है circular से. This is the my plan view. This is the plan view. I want to repeat. Axis कौन सा है? Vertical Y. Okay. Node कौन सा है? This my 0. 0, 0, 0. कितना है? 360 degree. I want to rotate this beam through 360 degree. Number of steps 98. Okay. I just click on OK. So now I have created 98 segments here. Okay. So just select this up, our first and the second one. You can select first and this also anyway. I will just select these two beams only. Just make new view. Okay. Now, अभी हमने क्या किया है? Now what we have done, we have divided our plate in this direction, circumferential. So now we have to divide our plate in radial direction also. So what is the radius? 6.6. So I will divide it by again 0.2. 6.6 divided by 0.2. So I need 33 segments. Okay. So round figure, ठीक है, 33. That is okay. But at this location, it will be very difficult. So maybe I will just go with, if I consider only 500 meter, then 6.6 divided by 0.5, 13.4. So I consider 14. So what I can do, I just select these two beams, right click, insert node. I will add endpoints. I need 14. That's why I just put 13 points here. Okay. So understand, if I go with the 33, I will get some very close nodes here. That's why I cannot even see this. So just to avoid that, I just stick with the 0.500 mm thickness or segment. If you can measure this, you can see this. Because we have ended up some round figure, that's why. Okay.
Yes, sir.
So now we have to create plates. So now we don't have any restrictions for the local axis. So take a liberty and you can create plate as per your requirement, but just follow that pattern. If you start from bottom left corner, you can repeat that same for everyone. You have to create plate for this. Now I have only 3 nodes, so I cannot go with this 4 node plate. So for that, what I will do, I will just select 3 node plates. This will be a triangular plate. We don't have any options. So this case will be somewhere at the end. So we have to be ready with that. So this way we have created one small strip of the plate of entire base slab. Okay. So now what you need to do, select all plates. Again, go to the circular repeat. Y will be always be there. 360 will be there. Select node, this as a origin, select this one. And instead of number of steps, 98, because we use that. Click on yes. Now you have created plates here. Your base slab is ready now. Got it?
Yes, sir.
Okay, so now you can select all the beams. Actually, those are not required, but still I want to, because those beams are just for the construction purpose. So ideally this is not required, but still I just want to keep those for some time because we need that beams for some time. After that we will delete. Okay. So these are the plates. So just right now, just create some groups. Plate, water, load. Because these are the plate which is subjected to the vertical pressure of the water load. Correct? Okay. Select plate, all plates, and assign this. Just check whether it is added or not. Okay. Now we want to add the vertical wall. And what is the height of that wall? Just go to the section. Can you calculate height? 127.35 minus 123.25. 27.35 minus 23.25. 4.1. Height of the tank is 4.1. Okay. So now how to put the wall? For that, what we have? We have run structural wizard. So go to the run structural wizard. In this, select surface or plate models. Okay. Out of that, select this cylindrical surface. Okay. After selecting this, you will get these parameters. So we have to fill that. So what is the length? Length is 4.1. Start radius, that is 6.6. What is the end radius? Same, because we have uniform radius, 6.6. Sweep angle 360 degree, that is okay. Division along periphery, how much? Correct. So remember that figure, 98. And division along length. So 4.1 is our height, 4.1 divided by 0.2. 20. Thickness is a 0.2. So round figure 20, not 200. 20. Okay. Now see this axis. These are very interesting things. Axis 0, 0, 0. So Just check preview, apply. Do you want to place like this? If I double click it, can you see this? Z is 0 and end is 1. This is our Y, this is X, and this is Z. So if you want to put this wall like this, so it is not correct properly orientation. So what we need to do, we need to check this.
Z1.
Is it correct the way?
Y.
No, this is also not correct. So you have to always be there.
Endpoint Y1.
Is it correct? Correct way?
Yes, sir.
Yes.
So we want to play like this. So always Y and 1. So if you just instead of this, you will get some different orientation. I'm just want to say. So 1, 0. Okay, now this is the correct way. Just before that, check the units, select units, meters, that is correct. Okay, now you can merge this with your STAD. Merge model with the STAD model. Okay, would you like to transfer or merge this model? Yes. So now it will ask you the coordinates. Okay, so now yes, so everything is at 0, 0, 0. So we don't want to provide it unless until if you have some different things. Okay, so I will not change anything. Okay, so this dialog box should be get, means we have perfectly matching nodes of wall to the base slab. If not, then definitely something is incorrect. Can you see this? The bottom nodes of the wall and base slab is perfectly matched. Okay, this should be very important. If those nodes are not matching, then your load path will not be correct. You will get errors in your analysis. Okay, so maybe I will just undo and I want to show this what happened. Oh, it is run structural wizard, go to the plate model 4.1, 6.6, 6.6, 30, 90. Instead of 98, if I by mistake, if I forget, and instead of 98, if I put something 96 or 97, this is 1, 0, apply. Okay, now you can see that note will be okay. Some nodes, duplicate nodes are ignored, but can you see this? These nodes are not perfectly matched. So when you go with that for analysis, you will get some error. Can you see this? Can you identify this?
Yes, sir.
Yes,
Nodes
sir.
of the base plate and nodes of the wall is not matching.
There is a difference. Yes, sir.
Yes, so it is not allowed. So that's why we should have perfectly match this. Okay, again, I will just again add and I will save it as a final things. Geometry, run structural wizard, plate models, 6.6. No,
4.1.
4.1. Okay. 98. 0. Yes. Okay. Done. Save. Just immediately create one more group for wall. Select this, highlight, select inverse plate. Select all plates and associate. Okay. It is not selected properly. No problem.
Even the base plate is selected, right?
Yes. So that's why I'm assigning again. When we did that undo, that was it was just get deleted. Okay. Is it okay now? Water load. Okay. Now we will assign wall plate. So highlight, select inverse plate. Now select all the wall plates, associate. Just check again. Base slab, wall plates, done. So now next we need to add toe also. Okay. How to add that toe? So what is the toe width? It will mention somewhere. Toe. Yes, 250. 500. 500. Okay. So center to center, 100 plus 500 means 600 that we need to go beyond that wall center. Okay. Because we have 200 mm thick. So from wall center to wall edge, 100 mm plus 500. So how to add that toe? Okay. Again, go to the top plan, select all the beams. Okay, select all the beams. So select this one, the first one, which is perfectly horizontal to this. So check the dimension, 0.9. And for the first one, 0.47. So what we can do this, we can just copy this two beams, copy this reference point, select endpoint. Okay, again copy this reference point, endpoint. Now merge this beam. Merge selected members. Okay. Same thing with merge select members. Okay, now we have only one beam. And now we want to add one node where at 0.6. So select these two members, insert node, add new points or new points by distance 0.6. Okay, so now this is 0.6. Maybe you can check it. 0.6, 0.6. Delete this. We don't require. Yes, save. Now, okay. So we have this toe beam here. Now again, draw a plate. Select this plate. Go to the circular repeat. Select this node. 0, 0. 360 is fine. 98. Done. You got it? Now we have all the toe plates also here. So create one more group. Two. How to assign? Select water load, highlight. Select water load, highlight. Select by inverse plate. Select wall load, highlight. Select by inverse plate. Now you can select this, all the toe plates. Okay. Now we have created toe plates also. Now we want to add central wall, which is going to support the bridge. So what is the diameter of that central bridge? (200 mm wall thickness), and yes, 600. So 800. So we need to add a central pillar of diameter of 800. So just go to your slide again. Or maybe just keep open only base slab. Check any node. 0.47. So maybe we will go with this. Otherwise, what we need to do, we have to adjust node at 0.4. Okay. So just check it's 0.471, because this one will also give a problem. Otherwise, 0.471. I can go to the run structural wizard. Solid length 4.1. Start radius 0.471 divided by 2. That is 0.2355. 2355. Same 2098. This will be 0. This will be 1. Apply. Merge with the STAAD model. Yes. Okay. We will get some notification. Duplicate nodes will be get eliminated, something like that. Because all the other things are hidden. So just check whether it is perfectly all right or not. Looks good to me. There is no difference for the plate nodes. So create one group again. Create one group plate. Central column or something like that. Select plate. Associate. Done. Save. Maybe we will stop here. So in next session, we will complete the STAT modeling of the circular clarifier or circular tank by adding Launder channel, and we will apply all the loads to the circular water clarifier, and we will design it, and we will finish the circular water tank if possible to the next session. Okay.
Okay, sir.
Okay, we will stop here. Yes. Thank you all. Good night.
Good night, sir.